Welcome to another episode of Podcast Name, where we dive deep into the fascinating world of technology and creativity. Today, we're exploring a cutting-edge technique in visual design, surface-stable fractal dithering. This innovative form of dithering was developed by Rune Johansson and is particularly useful in creating stunning visuals for 3D scenes. So, what exactly is surface-stable fractal dithering? Imagine a world where dots, those small pixels that make up our digital images, stick to surfaces dynamically, behaving consistently as you navigate a 3D environment. That's what this technique brings to the table. Unlike traditional dithering methods, which can often lead to inconsistent visuals when objects move closer or farther away, this technique cleverly ensures that dots maintain their size and spacing on the screen. How's it achieved? By dynamically adding or removing these dots as needed. Let's think about it this way. It's like a piece of artwork that adapts to its frame. As you move closer to the painting, the details don't swirl into chaos. Instead, they hold together, providing you with a seamless viewing experience. Now, for those of us who might not be as tech-savvy, can you explain how this process works? Well, to put it simply, it utilizes something called dither properties. Each material using this dithering technique has specific settings, such as dither input brightness, which controls how bright the dots appear, and dot scale, which helps to scale dots exponentially. One particularly interesting feature is the radial compensation. This aspect is especially crucial when using a perspective camera. You see, for the dots to remain stable under camera rotation, they need to appear larger towards the edges of the screen. So, by turning on radial compensation, the visual experience becomes more consistent, regardless of your angle. And there's more. The dither setup allows for what they call dot contrast, achieving a level of anti-aliasing that truly enhances the overall visual quality. It's like a magic wand for shading that ensures everything looks great, no matter how you're viewing it. Now, I know this can sound pretty technical, and you may be wondering, where can I see this in action? Great question. There's a handy Unity example project available that demonstrates these concepts in a practical way. Unity, for those who may not know, is a popular platform for creating 3D applications and games. This project not only showcases the dithering technique, but also includes the shader and texture source files, allowing others to play around with it more easily. So for our listeners who are into game development, this could be a fantastic resource to check out. Speaking of resources, the original project is housed on GitHub, where you can not only find the shaders, but also the textures that are integral to the dithering process. This includes various 3D textures with different amounts of dots. You can actually switch between these textures as needed in your materials, making it a flexible tool for artists and developers alike. Now, let's pivot briefly to something more fun. Imagine being able to create your custom dithering patterns. The repository even includes a script that lets you generate these textures from scratch. Imagine how empowering that would be for an artist or a developer wanting to craft a unique visual style for their project. Before we wrap up, let's touch on the licensing aspect of this technology. This implementation is licensed under the Mozilla Public License v2.0, which means any changes or improvements you make must be shared with the community. But the great news is that your own game or application's source code remains yours, meaning you can create proprietary games using this technology without any restrictions. As we come to a close, it appears that surface-stable fractal dithering isn't just a technical advancement. It's a leap toward enhancing the way